Backpropagation through time. Recurrent neural networks are those networks that deal with sequential data. In this, the current output depends on current output as well as a memory element. In this way, we continue to update weights at time. The value of delta W becomes negligible. That is no change in new weights. This problem is vanishing gradient. Vanishing and exploding gradient. Vanishing descent, gradient descent, a fundamental optimization algorithm, can sometimes encounter two common issues: vanishing and exploding gradients. Vanishing gradient. This problem is a challenge that emerges during backpropagation when the derivatives of slopes of the activation function becomes progressively smaller as we move backward through the layers of a neural network. Exploding gradient problem is a challenge encountered during training deep neural network. It occurs when the gradient of the neural network's loss function with respect to the weights become negligibly large. Truncated backpropagation through time is a method for learning recurrent neural network that's more efficient than backpropagation through time for long sequences. Gated recurrent unit like LSTM, GRU can process sequential data such as text, speech, and time series data. The basic idea behind GRU is to use gating mechanism to selectively update the hidden state of the network at each time step. The gating mechanisms are used to control the flow of information in or out of the network. The GRU has two gating mechanisms called the reset gate and the update gate. Long short-term memory is an improved version of recurrent neural network. LSTM can also be used in combination with other several network architectures such as CNN for image and video analysis. The memory cell is controlled by three gates: the input gate, the forget gate, and the output gate. These gates decide what information to add, to remove, and output from the memory cell. Encoder decoder models. An encoder model in deep learning is a part of a sequence to sequence model that processes an input sequence to produce a fixed size representation. The encoder model is typically made up of a RNN that summarizes the input sequence into a context vector. The context vector is then passed to a decoder model which generates an output sequence. The decoder model is a part of the encoder decoder model, a neural network architecture that uses RNN to solve sequence to sequence prediction problems. An encoder decoder model is a deep learning framework that uses two neural networks to process input data and produce an output. Encoder processes the input data and transforms it into a fixed shape. Decoder maps the encoded state to a variable length output. Encoder decoder models are used for sequence to sequence prediction problems such as machine translation and question answering. Attention mechanism. It is an encoder decoder kind of neural network architecture that allows the model to focus on a specific section of the input while executing a task.